We'll see. Maybe we finish, maybe we don't. Okay, so this we talked about spam blogs, talked about search data, yes, search operations, right. We went through the tech. We went through onion routing, stuff like that. Okay, so now we're ready to talk about the other two parts. Trying to kill those lights for you. There we go. We're trying to talk about the other two parts. So remember the parts we had were crawling, indexing, and retrieval. So we covered crawling in a little bit of detail. We'll cover indexing now. So all the pages that Google visits, right, are stored in this giant internet scale database system. Because basically Google has a copy of everything, but not just a single copy, a triple copy for reliability, and not just a triple copy because there's also cached versions of the pages. There's older versions that it keeps. Plus, it also has another database that it keeps distilled data from all these pages. So it's actually bigger than the regular surface internet. Anyway, Google's indexing system looks at text, right? So frequency, location, combinations, how the text appears at a page, on a page, images and videos, and page metadata, like creation and revision dates. So all that information Google keeps. The main repository is a set of document servers. Now, all the sorting details are basically Google's special sauce. They're part of a big, secretive trade secret type operation. So they don't give you a whole lot of detail. But what we know is Google takes copies of the pages and stores them in this big document management system. And remember, this is kind of something that makes sense to do in a NoSQL type structure because, right, all those things, there's not a standard structure to it. You really don't want to create a giant relational database for documents. Okay, well, we'll talk about indexing generally. So, suppose you have a library full of books, like, the library over there. You have a library full of books, and you need to find information on a particular topic. So, obviously, you wouldn't scan every book to find matches, right? You wouldn't start at the first book in the library, read through the whole thing, see if you found anything, close it, then go to the second book, do the same thing, and spend the next 100 years in the library doing that with all the books. Instead, you would have some kind of index to guide you to a much smaller subset of books that might probably have something relevant about the topic, right? We understand how to look for books in the library. Anyway, same thing at Google. So, essentially, for every search term or group of related search terms, the index holds a list of all pages containing the term. So in essence, what we have is this. Basically, it's like a key value store where what? The key is a set of matching index terms, right? So basically indexes that all mean the same thing. So it could be, what's something that has multiples? I'm bad with stuff today. Well, there are certain people that go by multiple names, right? That they become famous in history under one name, but their real name is actually somebody else. Yeah? So the one that will come up if we get to. So Galileo, right? What's his first or last name? What's Galileo? Is that his first or last name? That's his first name. What's his last name? Yeah, or Galilei, but either. Yeah. Okay? So those are both the same. Right? For practical purposes, hardly anybody is searching for one of those that's not meaning the other. He's a significant historical figure. So that could be a pair of keys. Right? So in this case, we actually have multiple keys pointing to the same value. And then value, complete set of pages containing one or the other as text. Okay? That's literally, the value here. So, in this case, since these two terms are so closely, related, you wouldn't want to probably carry two separate entries for those. Even though there probably aren't a whole lot of pages containing Galileo, it wouldn't make much sense. Let's see if I have internet, see if I can do this. Okay, so you will get some slight differences actually, but not much. So if I just do Galileo, I get 81,700,000. I do more specific one, 23,800,000, right? Because this is more referring about the guy, whereas this is kind of a catch-all that could include other things. Could include a lot of things like, Here we see things named after him, for example. Okay? So, yeah, in principle, the key should be one thing, but sometimes there's a lot of overlap. So the key is basically set of matching index terms, the value is a set of pages, and that's the basic data structure. Okay, now Google can do, in the cases like these, the way Google gets around this, essentially they can do tricks like this. They could say, okay, let's treat suppose the set of pages looks like this, right? And some of them, like this. So the Galileo Galilei ones are a subset, right? Because you can't have Galileo Galilei without having Galileo. So that, and then for the rest of them, do that in black. So they could do something like this if they wanted to be smart about it and if it was worth the trouble. Essentially, they could have the Galileo, right, linked to this batch. And they could have the Galileo Galilei linked to this batch, and they wouldn't need to duplicate the records in their database. Okay, so that's a possibility, but we don't have a whole lot of detailed knowledge like that about the way Google actually arranges their data, but something like this would make sense. So they don't need to store an extra 100 million pages that are just duplicated. Okay, does that make sense? Okay. Although I really want to hear from the people that it doesn't make sense for, but that's good. It makes sense. Okay. Anyway, so for every search term, set of search terms, the index holds a list of pages containing those terms, right? Now, typically as you get multiple search terms, you get a relatively small set of web pages holding them. But even so, searches for common terms can easily return several million, even sometimes billions of matches. Okay, so it's a big problem, they have to manage it. We'll talk more. We have our indexing and retrieval lecture coming up. Okay, another thing with indexing is knowledge graph. So Google is shifting towards a purer semantic approach to providing search results. What does that mean? Well, semantics is basically looking at what the words mean, what the search terms mean, instead of the actual text in them. So what they're looking for is one group of terms that is roughly equivalent to another set of terms, or is somehow linked, like one is a subset of the other. For example, right? If I do a search on Google for scientists, well, let's start with science. We'll do this. Okay. What are some branches of science? Let's start. What's a branch of science starting with A? Sure, astronomy. People always pick astronomy. What's a branch of science starting with B? All right, biology. At one lecture, I had people pick botany, but biology's fine too. C? Sure. What about D? Science branch starting with D? Dermatology? It is, but arguably a science. We could do that. Let's think. Can we come up with something better? I don't know. Sure. Dermatology. All right. The study of derm, which is actually a term for skin. So there you go. And if you want to do E, you could do entomology. Okay, whatever. Anyway, so the point is, there are all these sciences. There's this concept of something called a science represented by these various categories. Now, some of them are closely related to each other. Others are not. For example, it could be successfully argued that entomology, right, is a subset of biology, right? It's a specific set of creatures, bugs. Yeah? So you could have that kind of relationship, right? So each of these are sciences that biology is entomology. Likewise, there is some overlap in astronomy and chemistry, in the sense that a lot of astronomy is concerned with figuring out distributions of elements in stars and elsewhere, because they can use that to figure out how old stars are, things like that. There's some overlap there. Not as much, right? But there's not much overlap between astronomy and biology, for example. So different things here will have a closer or farther relationship. Some will be subsets of others. If we talk about another one, let's talk about famous people involved in astronomy. So first one, right, I'll give you a gimme. So Galileo. What else? Who's another famous astronomer? Sure, Copernicus. Excellent. Okay. Anybody else? Famous astronomers for 1,000? He's a physicist. I'm not sure if he's an astronomer. Yes, excellent. Now, what do we know about him? Since you bring up the name, what's interesting about him?
I know he died because he had to really use the bathroom at the dinner table, but that was kind of rude to excuse yourself.
Exactly.
His bladder burst.
Yep. As far as people can tell, that's the deal. So he was around, I think, in like the 1400s, and probably the 1300s. Anyway, so yeah, he was in Denmark, and basically in these days, if you were a scientist, you were basically patronized by somebody with a lot of money, typically a king or somebody, and they'd say, oh, this is, my pet scientist I keep around the house. And they'd pay you some money, and you'd do experiments and shit. So anyway, this king, where Brahe was working, he was giving a big banquet in honor of some celebration, probably like turning 40 or something, and drinking for a really long time. So, it's Denmark, so everybody gets really drunk all the time. And at the table, they're drinking like barrels of beer and whatnot, and he's got to pee. He realizes he got to pee, but the king is giving this long-winded toast, and one of the things in, that era, you do not get up and walk away from the table while the king is giving a toast, especially the king who's signing all your paychecks. So, he stayed there, boom, bladder burst, whatever, died from it probably horribly a few days later. So yeah, you can die from holding in your pee. Who knew? All right. Anyway, so that's kind of a side detail though. So we have these astronomers. We could put in a couple others, but this is fine for now. Galileo, unlike some of the others, has importance outside of astronomy, right? You guys know about that? No? He's, in some sense, significant in physics. He did a few experiments, like with acceleration, right? There's the famous thing, supposedly him about dropping a feather, dropping a rock off the Tower of Pisa, which probably never happened, but still that. And some other stuff with temperature and density. So if you've ever seen those thermometers with like the little glass bulbs of different colors, and whichever one is the right temperature floats to the top. Yeah, that was kind of his thing. So anyway, he has some significance in physics. So he's a person that bridges two. Well, what Google tries to do is categorize people basically in a sense with tags and finding out how they belong to different groups. So, for example, if you have the group, astronomers, he show up in that. If you have the group physicists, especially pre-industrial physicists, he would show up in that. If you had a list of people, famous people from the 1600s, he would show up in that. Or people persecuted by the church, right? Which there's a whole thing about that you can look up. He would show up on that list. So people would be, in various lists. And Google, when people are searching for stuff, if I search for Galileo generally, right, I get just him. I get what's called a knowledge card over here. Is basically a blurb talking about him. But then I have related stuff. So if I look up Galileo astronomy, it tends to recognize, oh, you know what? You might be looking for related astronomers, like Copernicus, like Newton, like Kepler, like Einstein. Einstein, not strictly an astronomer, but some of the stuff he did in physics was tested through astronomy. Okay? Likewise, I just do Galileo persecuted by church. Let's see what else. We got some others. So heresy, right? Famous heretics. No, nothing shows up with that. But Galileo discoveries, yeah, okay, he's got there. All right. There was another guy named Bruno who was actually burned. Galileo wasn't burned, but Bruno was. Galileo, Bruno, Inquisition. Yeah, Giordano Bruno. Similar guy, significant. Anyway, so Google tracks this stuff. Basically different ways that terms are related to try to group them together to understand how things are related semantically. So if I do famous astronomers, then I get into what's really the knowledge graph, these things. So a list of people that are all famous astronomers, and some of them might show up on various other lists. A lot of guys looking at the stars. All right. All right, and I can, all right, that's the short version. Google's trying to help people find related stuff, right? So if somebody looks up famous astronomers, that's essentially the structure that Google uses. It tries to recognize, okay, this is a reasonably common search, a reasonably common concept. We have a list of people that match this. These are the sort of things that people look for. Whereas if I look for famous physicists, okay, I get some similar ones. Newton, of course, shows up on both, Galileo on both, other guys from over the years. Anyway, that's the knowledge graph. Basically, Google maps one group of things that by categories that they're involved in. And so some of the big figures of, especially pre-industrial times like Newton, like Galileo, they tend to show up on multiple lists. All right. Okay. So essentially, Google tries to figure out the meaning of search term groups and then match to the meaning of web page content. To the extent that Google can recognize, that astronomy is a branch of science, then it says, oh, somebody who's looking for sciences might be looking for astronomy, or like different kinds of astronomy, for example, or different tasks within astronomy. It says, oh, that all falls under the heading of astronomy, right? So we could even look stuff like branches of astronomy. Okay, oh, the two big ones, optical and non-optical. So maybe you can recognize that somebody's looking for optical astronomy, maybe somebody's looking for non-optical, and you can group the results that way. Google's trying to analyze the meaning of the search terms so it can deliver better search results, not just, matching based on exact text. Okay. So that's enough. That's our, few slides intro to indexing. And the other part, retrieval. Okay, so first of all, Google data centers, right? This is an old link. It's from like 2012, but they're basically going to look the same. So Google throws open doors to its top secret data center, right? So there's a bunch of pipes, a bunch of ventilation. We have another picture here a little further down. You can't see? Well, you are getting the best technology that your tuition dollars can afford, that's for sure. All right. Collapse, please. Why won't you collapse? Damn it. All right. Anyway, let's see if I zoom out. Does that make it better or worse? A little better. All right, so anyway, Google data center, basically just a big warehouse or a big football stadium filled with 20,000, 100,000 servers. If this link ever gets going, it's still around. There's the picture I was looking for, right? So here, just an overhead view. All those things down in the middle there, that's just like endless racks of servers. Lots and lots of servers. Yeah, error occurred. All right. Fine. So short version, it's a big warehouse full of servers. Now, what happens when a search arrives? Google references the terms in its index to find the matching pages, right? So if I enter the terms astronomy, Google goes to the index entry for astronomy and says, oh, there's all these pages here, great. Then what it has to do, look at all those pages, rank them based on not only the search terms, but also any of my recent history, and then return me some limited subset of the best ones. So again, this algorithm is a closely guarded secret, but we know general principles about it, right? Some things we've already talked about, the presence of more than one term, the sequence in which they appear, term groups that have distinct meanings. So again, I do a search for something like famous astronomers, Galileo, 1600s, right? In this case, I'm probably not looking for a page that has those exact terms in sequence, right? I might find a page that has that, but what I'm more looking for is the general meaning of this. And Google has enough experience to map, oh, famous astronomers, that's something. Galileo, That's a semantically distinct thing. That's a person. 1600s. I'm not looking maybe for the specific term 1600s, but I'm looking for a stretch of time, right? Could be equivalent to 17th century, for example. So I mix all those together and I run the search. The retrieval process basically gives me a lot of detail there. Okay, so most famous astronomers of all time, he's included, just stuff about Galileo, blah, 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 other things. If the windows involved in the dates overlap with the 1600s, it gets that. So there's a fair amount of just, non-literal semantic processing going on. Okay, other stuff, also text versus objects versus metadata. All those can be considered as well. So not only the raw text on the page, but also the presence of relevant objects and looking into their metadata. For example, if there's a picture on the page and it's labeled Galileo, that would be considered an additional match. Okay. Other part, result prioritization. So retrieval, the first part of it is finding the set of matching pages. The second part is figuring out which ones you're going to see. Because if you do this kind of search, right, it says here, okay, you get 111,000 results, but you don't get all those pages. If we scroll down to the end here, we can see, in fact, we only have 130 results. So Google doesn't give us that whole 111,000 ever. They just give us, a slice of them, actually about 0.1%. The number one, right, people are going to look, they're going to look at the best matches. Number two, it would be a lot of extra wasted bandwidth and processing time to actually send you the whole complete list. So they don't do that. Okay. So, simple question though. Suppose you have many pages, all with the same search term. How should they be ranked, right? Imagine if you do a search on something like sports that gives you upwards of 20 billion pages. How do you go about ranking them, right? If all it's done by is just the word sports, right, and you know that the PageRank algorithm is kind of broken, how do you go about picking which one is better? Well, again, way back when, mostly about frequency, prominence, co-location of terms, right? So if you had a page that was saturated with a topic that had the word sports in it like 50 times, that was maybe the next best thing to maybe a page that only had sports once. They say, well, if this page has sports 50 times, it's all about sports. This page only has it once. Well, it mentions sports, but it's not really all about it. Okay? So, what Google tries to do is mimic how humans search. So, grouping text, even objects, into comparison units. For example, searching for the word shoe, right? Google recognizes based on experience, most people looking for shoes are not looking for information about shoes or how to make shoes. They're looking to buy shoes. So, if somebody just looks in shoes, well, Google's going to say, shoes, probably about retail. So we're going to look for sites that are identifiable as retail, right? So things with images, with prices, with drop-down style menus, whatever, that's going to be a better match for shoes. Likewise, a lot of times if people are looking for sports, they tend to be looking for one of two things. Either number one, recent scores, or number two, things about players in the news, whether players are switching for teams or just signing contracts, that sort of thing, tends to be what bumps up towards the top, just general sports news. Okay. Another thing, adaptive relevance. So, over time, users can associate search terms with very different goals. For example, certain searches are automatically assumed to be about the present, right? So if I look up the search weather 60601, it's going to assume I'm looking about, like a 24-hour forecast or something, right? I want to see what the near-term future weather is. If I look up the stock price for a particular stock, like PFE for Pfizer, I'm probably looking for the current stock price, not, a year's worth of historical data. Okay? Other things. Sometimes there can be a rapid and radical changing focus. For example, Harvey Weinstein, he's been in the news in recent years for some bad stuff. If you looked at him like 3 years ago, you'd find information about all the films he was involved in. If you looked him up 2 years ago, you'd find information about all the skeevy things he'd done over the prior decades. Likewise, local variations. For example, suppose the Kardashians are appearing in Chicago for something. If you search Kardashians in Chicago, then the Chicago users will probably get something about some upcoming appearance, but people in other parts of the world probably would not. And Google would recognize that by saying, all the people in Chicago that are Googling Kardashians, they're all trying to find out about their appearance, right? Where they're going to be, what they're going to do, that sort of thing. And Google will say, this subset of users, when they Google Kardashians, they want this. Other people in other parts of the world, they just want to know about their TV show or something. Okay. Anyway, so Google combines historical and predictive models to give the most relevant results. So it looks at past data, seeing what's going on, but it also includes some predictive models, thinking about, well, this is what we think people are going to be wanting to look at based on what we know. I mean, predictive models still have to be based on something, but there are multiple factors at play. All right. So one of Google's more recent innovations is factoring recent searches into the results, which I did in class the other day. So if you type in what, right, you get a whole lot of what options on Google. I just start typing in what. Oh, based on the fact that I've recently searched about Galileo and astronomy, right, I get a whole bunch about that, and then finally, what's that? Okay? Yeah, so it includes your recent search history, and depending on the things you've done, piles in more stuff. Okay. I did it with Ethernet, but yeah, we saw it right there. So again, algorithm is complex and secret, but we know some things. Number one, supported by search history. So things that you've actually searched for, that'll be a factor. Actual clicks, pages you've actually clicked on the links in the search results for, those are even given more weight, okay? Because it's like you found something that was interesting, that's probably what you're looking for. And all these rankings incorporate individual and global preferences. So global preferences, that's basically the whole world, all these people that are looking at searches, what all they're doing. But of course, your own recent history is given more weight for you in particular, right? During a particular browsing session. If you go out of the browser and you clear your cookies and all your other stuff, and you go back in, it'll be like you're Googling for the first time. Okay. Last thing, Google Instant. So in a sense, this is a predictive technology. So all this stuff, when we type in words, Google tries to guess, hey, maybe you're looking for this. So if I type in what is, actually, you know what, I'm gonna kill this because, whoop, I'm gonna do it fresh. So we'll see what we get here. What is, yeah, so if I do this, right, I freed myself from all this astronomy stuff. Anyway, so we have a bunch of things, right? Fine. And all those are based on like what people in the whole world are looking at. So what is my IP? That's been like in the top ones for as long as I can remember. But other things, they change, right? So CBD obviously is a pretty recent thing. What is mono? It must be going around. Good credit score? I don't know. Okay. So these things, some come and go. Likewise, we do stuff like simple phrases like who is? Well, let's see who is. Let's see who is trending lately. Who is? Who is Lizzo? Who is Toby Mac? I know who Banksy is. All right. No. Yeah, so there you go. A little after my time. My wife liked the Backstreet Boys back in the day, but yeah. Anyway, I have heard of the Backstreet Boys. I couldn't recognize any of them in a police lineup or a rehab operation. All right, so that's what Google Instant does. Basically, tries to figure out on some kind of global baseline, you enter in these terms, here's what people like you are also entering. So basically simple statistics, right? So terms that are popular come up a lot. Google thinks, well, you're probably like these other people. Other interesting thing, there is some filtering against defamatory and not safe for work results. So this one, summer of 2016, there was a thing, you guys remember Hillary Clinton, right? There was a thing with her and, what was the exact thing? Oh, yes. There was a thing with the emails where if you Googled Hillary Clinton if you started looking up investigation, because there was the email investigation going on, if you looked up Google Instant just kind of quit working on you. And a lot of people on the right said, oh my God, this is the proof. This is the smoking gun. Google's in the tank for Hillary. But if you do a similar thing with Donald Trump, what's something? Oh yeah, collusion, right? You get nothing. Well, the short version is basically Google's covering its ass. Anything that's like, still up in the air like this, basically Google doesn't want to be accused of, basically being involved in libel or that sort of thing. So they say, nope, if it's something bad about somebody, unless it's like a known fact that the crime happened, you're not going to get that through Google Instant. We're not going to be accused of pushing people toward a conclusion. So, interesting side note. All right. So there it is. Okay. Google search. Any questions?